Hey chemistry students, welcome to your tutorial with Charles' Law. Now remember in Charles' Law that pressure is held constant. That means that it's not changing. What is changing though are the variables of volume or temperature of a gas. So here's an example problem. 600 milliliters of air is at 20 degrees Celsius. What is the volume at 60 degrees Celsius? So my first step is to write my equation, and I already have that out. Now what I'm going to do is figure out what variables do I know and which one am I looking for. That's going to give me a better game plan. So I'm going to go ahead and just write those out in my little chart. Okay, so 600 milliliters of air. Milliliters is a unit for measuring volume. Doesn't matter that it's in milliliters. So I'm going to write this here. That's my first volume. All right. Is at 20 degrees Celsius. Now what you may remember from class is that when dealing with gases and measuring them, we use Kelvin because the Kelvin scale is directly proportional to the kinetic energy of gas particles or their motion, their movement. So I need to convert this number, 20 degrees Celsius, to Kelvin. And I'm going to remember Kelvin equals Celsius plus 273. So in Celsius, or excuse me, in Kelvin, my first temperature is 293 Kelvin. Now I'm asked, what is the volume? So that means I don't know this yet. At 60 degrees Celsius. Now, same thing as before. I need to convert that to Kelvin. So 60 plus 273 is 333 Kelvin. Now I'm going to plug into my equation. 600 milliliters divided by 293 Kelvin. Remember, it is important to write your units. This is a measurement. So a measurement has a number value and a unit attached. I'm going to set this equal to V2, that's the variable I'm trying to solve for, divided by my second temperature, 333 Kelvin. So we have a couple options here. We can cross multiply, or the butterfly method. I've also heard it called the Band-Aid method. So, or we can just try and focus on how do I get this variable all by itself. Either way, I'm going to opt for the second option. So my variable that I'm trying to solve for is being divided by 333 Kelvin. Now, what you may remember from algebra is that to get this all by itself, you need to undo what has been done to it. So I'm going to multiply this by 333 Kelvin. What I do on one side of the equal sign, I have to do on the other. Now when you multiply this side by 333 Kelvin, it's going to go on top. These are going to cancel out. I'm just going to be left with my variable. Now on this side, I have Kelvin on top, my numerator, and Kelvin in the bottom in my denominator. So I'm going to mark these out. Now my unit that I will have will be in milliliters. I'm going to write that down. Now I'm just going to plug into my calculator. So 333 times 600 divided by 293. And when I do that, I get that my second volume is 682 milliliters, which satisfies Charles' Law. Which Charles' Law is directly proportional. What does that mean? However you change one variable, so if you increase it or decrease it, that is how the other variable is changed. So for instance, our temperature it increased from 293 to 333. So our volume